Good afternoon, dear colleagues. It's 3 p.m. and we are about to begin our meeting. Our team of moderators is working with you today, Olga Bondarenko and Yelizaveta Stepanova. Welcome to the section GSD 2024, Geography for a Sustainable Future. This section is a part of the ICSF 2024 conference, the International Conference on Sustainable Futures, Environmental, Technological, Social and Economic Matters, ICSF, is a peer-reviewed international conference which is the premier interdisciplinary forum for social scientists, life scientists, engineers, and practitioners to present their latest research results, ideas, developments, and applications. The ICSF occupies contributions in all aspects of sustainable development, focused on the intersection of sustainability, environment, and technology, and their larger implications for corporations, government, education institutions, regions, and society both at present and in the future. Before we start presenting the reports, we would like to remind you of some of the rules of our cooperation. Please keep the time limit 7 to 10 minutes for the presentation on the report and 5 to 7 minutes for questions. We hope that you, like us, are in a safe place. If you have any questions for our speakers after the presentations, you can ask them in the chat or orally by raising your hand at the bottom of your screen in advance. The language of our meeting is English. And we apologize in advance if we say your name and surname with the incorrect stress. We thank you in advance for your participation in our conference and look forward to fruitful cooperation over the next 3 hours. For the 4th year in a row in May, we gather from all over the world to discuss sustainable development. Development that meets the needs of the people of today without compromising the ability of future generations to meet their own needs. The first speaker to present their scientific achievements invite us to discuss the problem, a machine learning-based CO2 emissions model designed for rental vehicles. We would like to invite Aola Yusfi to speak.
Entitled MLERV, short for a machine learning-based CO2 emissions model designed for rental vehicles. My name is Aola Yusfi. I work for Carbooker as a data scientist, and I have a PhD in data science. I'm here to talk to you today about our project to calculate or to make predictions of CO2 emissions prior to using the vehicle. So without any further ado, let me begin. Here is the agenda for this presentation. So first, we're gonna kick off with an introduction, then the letter to review before I get to our model, the MLERV. Next, the evaluation, discussion, and results. Finally, I'm gonna conclude this presentation and present future research directions. Okay, so the main objective of our project is to make predictions of CO2 emissions prior to using the vehicle. I'll give you an example. If you are a client, you go to our website and you fill in the form with your information and, for instance, your name, the rental period, the pickup station, the return station, your place of work, your home address, etc. All of this information, and us, based on this information, we're gonna make a prediction of CO2 emissions before you actually use the vehicle. So this is the idea here. Why is this important? Because of the growing focus on sustainability in the rental vehicle industry. So every car rental company needs to report its CO2 emissions and reduce it. Okay. While working on this project, many research questions were raised For instance, how to accurately predict CO2 emissions from rental vehicles prior to using them. A second important question is to how to develop predictive models for CO2 emissions estimation and how to accurately identify key factors influencing CO2 emissions. Which brings me to the literature review. The researchers grouped CO2 calculators into 4 major categories: calculators that use mainly the distance, a second category that uses the vehicle type, a third category that uses fuel consumption, and a fourth category that uses the average vehicle speed. In this same section, I'm gonna present the limitations of these state-of-the-art approaches and why they are not enough for our study of our project. Okay, behold on this table, please. It summarizes the key factors used by each category of calculators. For instance, if we take the calculators using mainly the distance, so they mainly use the distance and vehicle type along with other factors, but since we only present in this table the common factors for calculators belonging to the same category, so we only kept the distance and vehicle as the most common factors in this category. Same thing for calculators based on vehicle type. Then we have calculators based on fuel consumption. They mainly use fuel type, fuel consumption. The fourth and final category that is based on the average speed. They mainly use fuel consumption, speed, and vehicle type. So why these calculators are not enough for us as a rental company? Because they were not initially designed for renting or for car rentals. As a result of that, they don't take necessarily into consideration some features that are unique to that industry. For instance, the exact distance during a period of time during the rental period. Also, they don't profile drivers. As you all know, the way you drive your car influence how much CO2 you're gonna release. So an aggressive driver will have for sure will releases more CO2 than a gentle or a moderate driver. Also, they don't use precise information about the vehicle, such as the category, the type, transmission, etc. And they don't use the driver's place of work, its pickup station, return station, and it's his home address. So this is why we decided to develop our own model that faces all these challenges and that fits the unique requirements of the rental industry, the rental car industry. Now we're gonna move on to our model, so the MLERV. First, I'm gonna describe our data set, the data set we used to build our model. So we used the car bookers bookings data set, which at the time contained around 26,770 and a total of 114 variables. The percentage of missing values was about 15%, and the percentage of invalid records was about 32%. From all these variables, we only kept those that are more valuable for our project. So this table presents all the variables we kept. So we have the ICRIS code. I don't know if you are familiar with the term, but the ICRIS code is a code from 4 letters, and each letter refers to whether the category of the vehicle, its type, the fuel type, whether it's automatic or manual, So it kind of identifies the vehicle, and it's a it's a universal coding. We also use the mileage, the traveled kilometers. We use as well the period, the rental duration in half days, the included mileage, which refers to how much the driver can drive without incurring additional charges. We also use the home address of the driver, the address of his workplace, the pickup country, and the return country. Then we trained our data set on 4 different models: decision trees, random forest, Adabus, and XGBoost. Next, we're going to present the results we obtained for each one of these models. Okay, so we trained the data set on all these 4 models, and we divided the data into 80 for training, 20 for testing, and then 70 for training and 30 for testing. And we obtained better results with 80-20%. And as you can see, based on the metrics we used for we used RMSE, MAE, R squared, MAPE. So we obtained better results with the XGBoost model. Okay, let's conclude this presentation. So we first review the state-of-the-art CO2 emissions calculators before we showcase their key limitations in the rental vehicles industry. Then we introduced our model, MLERV, and showed why is our model more suitable for the rental vehicle industry more than the state-of-the-art approaches. Finally, we evaluated our model based on the metrics R squared, RMSE, MAE, and MAPE. And the results indicated that XGBoost has the best predictions. And you can go back to our paper to see all the details about the evaluation. We also compared the results obtained by our model to the results obtained by the state-of-the-art approaches, and we almost got better results than the state-of-the-art approaches. You can find all the details in our paper. As future directions, we intend to include more factors, for instance, the registration number, the vehicle model, and as well, as I said earlier, the driving style, which is very important in predicting CO2 emissions. Thank you, everyone. If you have any questions, I'm more than happy to answer them.
Dear speakers, thank you for your informative presentation. Dear colleagues, do you have any questions for the speakers? And we have one question in the chat from Ihor. One second, Ihor Holoshin. So how do you take into account the condition of the car? This indicator significantly affects the amount of your emissions.
Okay, what do you mean by the condition of the car? Can you hear me?
Yes, we hear you. I think that like the condition of the car means, like, for example, if the car is old or new, it affects like the amount of emissions, isn't it?
Yeah. Okay, I got your question now. So yeah, we take into consideration the model of the car. So the model, which means also the year it was created. So how much years it was used, so this I believe it summarizes all the condition of the car. If you see what I mean here. like the model and the year it was released, the car.
Okay, thank you for your answer. And we have one more question. Please tell us how relevant is the issue of achieving net zero carbon emissions for your country? Are there any government programs that oblige citizens of your country to significantly reduce carbon emissions by a certain year to prevent global warming?
Yes, indeed. In France, there are a lot of restrictions and regulations that especially car rental companies have to respect. And this is why they need to make predictions, report them, and as a result of that, reduce them if possible.
Thank you for your answer. Is anybody with other questions? Okay, so thank you a lot for your presentation and for your answers, and we can move to the next speaker. The next report will explore another aspect of sustainable development, exploring sustainable choices, consumer perception factors of millet milk consumption. We invite you to the talk, Sarshant Malik.
Greetings and namaskar to one and all. The topic of our presentation today is exploring sustainable choices, consumer perceptions, factors of millet milk consumption. The paper is written by Tanya Pampakal and Sushant Malik and Ravi Sharma. We are from Symbiosis Institute of International Business, Symbiosis International University, Pune, India. So the topic, I will first introduce the topic. The topic is related to millet milk consumption. Now, milk has been recognized as a staple Indian diet, and at the same time, we can also see that there are increasing or increase in the number of lactose intolerant people, and that has led to the demand of daily dairy alternatives. And there are also other reasons due to which the increase of dairy alternatives is growing in India. It can be ethical concerns, it can be, let's say, people adopting for veganism, etc. Now, plant-based milk, which we are studying exactly, millet milk, is gaining popularity due to its high protein content and low calorie content. At the same time, millet can be grown in almost all soil types. There are many types of millets grown in India. They require less maintenance, comparatively way less water than other crops, and they can be called as sustainable crops that has the potential to meet the food security needs of the country. Now, therefore, it is an ideal crop that can be used as a dairy replacement through value additions. I would also like to add here that millet is also being preferred as and being consumed in also other forms in India, like it can be a protein bar, etc. Now, in this context, we want to study what are the crucial factors for the which can affect the consumer purchase of millet milk in India. Now, we collected the data and insights from the people regarding the millet milk consumption and their consumers or the potential consumers. We have used binary logistic regression in which we have taken the dependent variable as whether the person or whether the consumer will purchase the millet milk or not, and it has been regressed on the factors like age, gender, veganism, education, curiosity to consume new foods, dietary preferences, whether dietary preferences, environmental concerns, taste, ethical concerns, etc. And we have also given the detail of different variables that are there and the measurement of those variables. And according to the literature, whatever we have found in the literature, we have also uh, shown the expected signs of these variables, which you can see. Now the results again, the questionnaire was the responses that we got were from 178 respondents, and 90% of the respondents were aged 20 years and above. Females comprised almost half, while again the other half was males. Only 12% of our sample were vegans, because in India there are veganism is being adopted, but again there are comparatively less number of vegans in India. So again, this the number 12% can be attributed to the population sample. 90.8% of the individuals were qualified and were undergraduate and above. Now, these are the results of the binary logistic regression and the factors that influence the consumption of millet milk in India. The significant factors here are education, veganism, and ethical concerns. It is also to be noted that for education, the sign is negative, that we will discuss in the next slide. Now, ethical concerns about animals significantly influence the purchase with a beta coefficient value of 0.33. That means there are more ethical concerns, individual that have ethical concerns towards the animal, and there are greater chances that if ethical concern is being advertised as an attribute, they are more likely to shift towards uh, plant-based milk or millet milk. And veganism is also one of the factor that is positively associated with millet milk consumption. Now we can see the sign of education was negative, that is significant in negatively influencing the plant-based milk consumption, and that can be attributed to over the years advertising of how plant-based milk or cow-based milk, buffalo-based milk is healthy. That has been advertised in India over the years, so that can be attributed to that. Also, we can say that millet in India is more has been earlier in earlier years, it has been more of an inferior good. Now, because it has been inferior good, people are less likely to understand that it has that kind of benefits that as compared to plant-based milk. So educated people have that kind of bias towards milk. So to conclude, veganism is one of the major factor that companies can take it as an attribute to advertise millet based milk. It is also ethical concerns, and there needs to be, let's say, awareness regarding millet milk among the educated people, among the urban people who are actually going to adopt it first as compared to rural people in India. So promotional activities need to be advertised, uh, taking veganism, ethical concerns, and awareness needs to be there regarding millet milk. So thank you for attending this presentation.
Thank you, the speakers, for your interesting presentation. And now we are ready to ask some questions.
Hello,
And
sorry.
we have one. Okay, sure.
Oh, yes, sorry. Can you hear me now?
Yes, we
Yes,
hear
I
you
can hear
well.
you.
Okay, thank you so much for your presentation. That is actually, I would like to say that it's quite actual topic for me. But you were mentioning a bit of about like environmental aspect, and I would like to know like how significant is the correlation between the increased consumption of plant-based milk and the improvement of environmental situation, because I have like more overall picture and understanding that yeah, it has connection definitely, and it's supposed to have some impact on climate change as well. But could you please make it like more specific for me, or
Yes.
over like what numbers of people should like what numbers of people can impact this situation like globally, let's say, if I hope you got my question correctly.
Yes. So for our sample specifically, we collected the dependent variable as whether the person will consume millet milk or he will not. So for our sample, mostly our consumers were the sample was mostly urban, and mostly the sample were educated individuals. But for our sample, environment was not a factor of concern when preferring to millet based milk. So for us, it was insignificant. But yes, you are right in that sense that yes, that is the kind that should have been a relation. But because we have selected the variable as whether they will consume millet milk or whether they will not, environment was insignificant. Mostly because I can say because people are not aware of the fact that millet as a crop is a very sustainable crop. So millet as a crop can be grown with less water, can be grown in any soil types, has comparatively very less cost as compared to other grains like rice and wheat. So people do not know that. That is why maybe in our sample that didn't reflected that whether if you will shift to millet based milk, environment was not a significant factor for this sample.
Okay, that's clear now for me. Thank you so much for your answer.
You're welcome.
And we have one more question in chat
Yes.
from Ihor Holoshin. And the question is, what is the geography of consumption of different types of milk in your country?
Perfect, sir. Mostly in mostly all the parts of the country, the major consumption is of cow and buffalo milk, and very less percentage of milk consumption from other animals. And the millet milk consumption is very least. It might be only in less than 1%. But given the size of market of milk consumption in India, it has a great potential.
Thank you for all your questions, for all your answers and all the questions. And now we are continuing our work. And the next report will be below ground carbon stock of mangrove stands of a mining site in Hainatuan Island, northeastern Mindanao, Philippines. And we invite to speak Judeline Petro.
Good day, everyone. My talk is entitled Below Ground Carbon Stock of Mangrove Stands of a Mining Site in Hinatuan Island, Northeastern Mindanao, Philippines. This is my outline, and this is our abstract. Now, biodiversity in the Philippines is rich. It's considered top 15 most mangrove-rich countries in the world. It is recognized as one of the 17 mega biodiversity countries because of its high endemism rates, varied ecosystem, and mangrove diversity is relatively high. Maintaining 5% of the world's flora, it ranks sixth internationally in terms of the number of plant species. These mangroves play a crucial role in ecosystems or coastal ecosystems, serving as significant carbon sinks that help mitigate climate change. However, these ecosystems are increasingly threatened by human activities, particularly mining. The disturbance caused by the mining operations can impact the carbon storage capacity of the mangrove forest, potentially reducing their effectiveness in carbon sequestration. Thus, this study aims to investigate the below-ground carbon stock of the mangrove stands in Hinatuan Island where mining activities are prevalent and compare it to the carbon stock of the natural mangrove stands in unaffected areas. These are our objectives. First, to determine the mangrove characteristics in terms of height and diameter at breast height. Second, determine the variation of soil carbon content with depth in natural and reforested sites. And third, to assess if there is a difference in below ground carbon storage capacity between mangroves in reforested site and natural site. For the methodology, so this is the Hinatuan Island. Particularly, the red star is the sampling site, and this one is Kagutsan or Barangay Kagutsan. Particularly, the sampling site is here in the gray star. So, Hinatuan Island is located in Barangay Talavera, Municipality of Taganaan, Province of Surigao del Norte. It maintains an average annual temperature of 26.7 degrees Celsius and receives around 320 millimeter of precipitation annually. Its soil primarily belongs to the feral soils category, categorized by clay loam composition. Hinatuan Island has a total area of 1,275 hectares and significantly affected by the mining activities. Nickel mining operations in this place have notably been active on the island since 1980s. On the other hand, Barangay Kagutsan is situated within the city of Surigao, still in the province of Surigao del Norte. Currently, the barangay encompasses 12 hectares of mangrove forest. The prevailing climate in the area corresponds to type 2 based on the Corona classification system. The soil type in Barangay Kagutsan is classified as histosols, primarily composed of organic materials. The area is under the protective oversight of the Department of Environment and Natural Resources and the local government unit of Barangay Kagutsan. Now, the field sampling design is that there are 150 transect lines perpendicular to the beach that was established, each spaced 50 meters apart. Each of the 150 line transect, two 10 by 10 non-destructive quadrats were designated, referred to as zones. A comprehensive inventory was conducted covering 100% of all trees with a diameter of at least 4 cm. For each tree, species were meticulously documented, diameter at breast height using a tape measure, and a clinometer for the overall height. These three parameters for each field plot were considered to estimate the soil carbon pool, namely the soil depth, dry bulk density, and the organic carbon content. For the carbon or soil carbon stock determination, soil samples were randomly taken from the two sampling sites using soil corer of 100 centimeter high and 6 cm in diameter. Soil samples were partitioned into depth intervals of 0 to 30, 30 to 60, and 30 to 90 cm. Samples representing each depth were collected as subsamples and were analyzed for soil carbon content using the Walkie block method. Subsamples also were taken at the midpoints of each depth and is used for bulk density determination. Samples were then oven dried for a cumulative duration of 281 hours at a temperature of 60 degrees Celsius. The dry mass was subsequently measured to assist the calculation of the bulk density using this formula. For the results and discussion, now this is the mangrove composition of the two sites. Rhizophora apiculata dominates both Lipata and Kagutsan areas, accounting for 85.70% and 71.80% respectively. The Lipata site has a total count of 171 individuals, while the Kagutsan site has 206 individuals. Figure 4 is the mangrove diameter and height distribution. Figure 4a shows the Kagutsan site has a greater number of individual mangroves compared to the Lipata site. Figure 4b, similarly, the height of the mangroves in the Kagutsan are taller, indicating that they are more mature compared to the mangroves near the mining site. Based on the diameter at breast height, both the natural and rehabilitated sites show similar average DBH of 6 cm. For figure 5, this illustrates the soil carbon content increased with depth. Now, it is in the 50 to 100 cm depth where significant difference of soil carbon was observed compared to the shallower depths. For Lipata, post-hoc comparison using Tukey's HSD test indicates that the soil carbon content of the rehabilitated site at depth 50 to 100 is significantly higher compared to the 30 to 50 cm, 15 to 30 cm, and 0 to 15 cm. In Kagutsan, the soil carbon content is also lowest at 0 to 15 centimeter. Significant difference was also observed in the soil carbon content between soil depth. Based also on the post hoc Tokes HSD test, 50 to 100 cm is significantly higher compared to the shallower soil depth. No significant difference was found in the average soil carbon content across the transect, traversing from the landward to the seaward zones within each of the natural mangrove sites of Kagutsan and the rehabilitated site of Lipata. Finally, comparing the mean DBH, height, and carbon stock of mangroves provides an insight of the mangrove stand carbon sequestration potential. The mangrove rehabilitated site of Lipata has similar mean DBH, height, and below ground carbon stock with Kagutsan. Hence, the rehabilitation efforts of the Lipata site in Hinatuan Island must be continued and should also be implemented in the nearby damaged mangrove ecosystem. Thank you and good day once again.
Dear speakers, thank you for your informative presentation. And dear colleagues, do you have any questions for the speakers? Okay, so we have one question from the chat from Ihor Holoshin. How does global warming affect the health of mango forests?
Hello, good evening. I
Hello.
good evening from the Philippines. Okay, Ma'am Weng, I need to call my friend, my colleague. Hello, Ma'am Weng.
Yes, I think um, global warming affects the health of our mangrove forest when the temperature of the sea increases, and so is the health of our mangroves. They don't really grow that fast, and they don't produce. They don't. Their productivity decreases because of the changing water temperature. Yeah, that's my point. Thank you.
Thank you for your answer. And we have one more question. What is the practical value of your research?
Um, we are trying to determine if the rehabilitation effort of the mining site is efficient or effective. Hence, we compare the soil carbon content of near the mining site and that one from the far from the mining site. And so we found out that there was no significant difference in terms of the soil carbon content. And we concluded that perhaps there's two actually uh, idea there is that um, the rehabilitation effort of the mining site is effective as there is no significant difference between the sites, and the other one is the mining activity does not affect the soil carbon content of the mangrove ecosystem, although it does affect the mangrove forest because there is as you can see, the mangroves near the mining site is less in height and less in diameter at breast height compared to the one that is far. But in terms of soil carbon, they have no significant difference.
Okay, thank you a lot for your answers. And does anybody have any questions? Okay, if nobody has any questions, we can move to the next speaker. But dear colleagues, before announcing the topic of the next report, We would like to thank our guest Sergei Kobzan from the Beketov-Kharkiv National University of Urban Economy, who is now defending our land and guarding our peace. We bow to you, colleague. And we continue and give the floor to the speaker, Olena Pomortseva, with the topic Application of Geoinformation Systems in the Development of the City's Intelligent Transport Network.
Good afternoon, dear colleagues. I am Sergei Kobzan from Beketov National University of Urban Economy in Kharkiv. The title of my article is Application of Geoinformation System in the Development of the City's Intelligent Transport Network. Relevance of the topic formulation of the problem. Ground urban transport is one of the main elements of urban development. This became especially noticeable during the so-called blackout. It was due to the proper management of the city's ground, hence that the plan of the high-quality transportation of the population was implemented. The development of motor vehicles is inextricably linked to the growth of the urban population of the servicing of its needs. The stable operation of this sector of the city economy allows you to save time for trips due to the rational distribution of roads around of the city. Ground urban transport is one of the great social importance. Not all areas of large cities are sufficiently covered by the transport network of roads to meet all the needs of the population today. On this slide, you can see a view of the polygonal layer modeling. The transport structure of the city of Kramatorsk was chosen as the object of the study. The total length of the transport roads in the city is 347.7 kilometers. Transportation is carried out of, transportation is carried out on 22 bus, 3 tram and 6 trolleybus roads. That is, all public transport is ground. In order to solve the existing problem, it was decided to introduce a system and high-speed bus transportation. For that, it is necessary to make a geoinformation analysis of the city's transport infrastructure based on data on the population's accessibility of transport infrastructure facilities, in particular public transport stops. This will reveal the weak points of the formation of the passenger transportation network. A database was developed in the ARGIS software product to solve the task. Level of accessibility to public transport stops. On this slide, we can see a picture named buffer zones around stop along of the network of transport roads. One of the main indicators of characterization of the level the public transport service is the availability of public transport stops. This indicator is expressed in the distance of walking approaches to stops. normative requirement required to access the range of more than 500 meters. Analyzing the attribute table of the creating geodatabase for the population and population in the buffer less information was obtained for specific area regarding the total area of a residential building in the area in kilometer square and the area included in the 500-meter walking distance to stop. In the article, the author concluded the percentage of the urban population that has pedestrian access, the public transport stops. Thus, it was established that a level pedestrian accessibility to public transport stops is extremely low, from 0 to 40%, 9 districts. From 40 to 60%, 5 districts. From 60 to 80%, 8 districts. And from 80 to 100%, 1 district. As a result of the calculation, the author determined the level of pedestrian accessibility to public transport stops in the city Kramatorsk with 42%. System of high-speed bus transformation you can see for this slide. In our opinion, the introduction of system is high-speed bus transportation in the city will be able to solve problem with connecting remote areas and city center. To implement such a modern transportation system, the following step must be performed. The first step should be creating the concept of trunk roads. Dedicated lanes for public transport should be organized on the main roads that will connect transport hubs. The right of use these lines should be reserved exclusively for bus for the high-speed transportation system. The second step is the introduction of the transport intelligence. They ensure fast delivery the passengers of transport hubs. It is proposed to introduce regional local roads. Result. First, the article creates a geodatabase with the necessary classes of object for the analysis for the indicators for improving the city's social infrastructure in the future. Second, the authors analyzes the degree of pedestrian accessibility of the population to public transport stops. Third, in the work, transport roads are designed use the ARGIS software project. And the author proposed the high-speed bus transportation system that improves pedestrian accessibility to public transport stops by 30%. Conclusions. The system proposed by the authors will exert pedestrian accessibility to public transport stops by 72%, which 30 higher than existing one. It is basic and in the event and its implementation a number of discussion must be held with participation of expert and community representatives. The practical significance of the obtained results lie in the application of geoinformation technologies in development of high-speed bus roads in the city Kramatorsk. Such a solution to the problem will allow connect remote parts of the city and help improve the lives of citizens from the point to view the transport infrastructure of a smart city. Thank you for your attention.
Героям слава. And thank you to the speakers. You were very convincing. By the way, this team of speakers are taking part in our seminar not for the first time. And we are really thankful for you for your researches. They are always very interesting and informative. And does anybody have any questions? We have one question in chat. What vectorized data is the basis of the study and for what time interval?
No, one. The intelligent transport network of the digital city is a network designed with the help of GIS. This network takes into account and is able to process a large amount of data. In the article, we developed a network that improves the movement of city transport by more than 30%. In the future, we plan to add elements of artificial intelligence to the model of this network.
Okay, thank you. And we have one more question. So, what does a smart city transport network mean? And how does intelligent transport differ from traditional transport?
Hello, dear colleagues. Can I speak for your questions?
Yes, we can send our question in chat or I could repeat it.
Excuse me, I see questions from my colleagues. No questions.
No, we have one more question. Like, what does a smart city network mean?
Okay, I ask for this question. Yes. In our article, we research intelligent transport network. The intelligent transport network of the digital city is a network designed with help the geoinformation system technologies. And we developed a network that improves the movement of city transport by more than 60%. And in future, we plan to add elements of artificial intelligence to the model of this network. Thank you for your question.
Thank you for your answer. And we have one more question in the chat. The question from Ruben F. Ampredo. How are the pedestrian stops located in the city? What are the basis of such location?
Excuse me, your question about location?
Yes, like where are the pedestrian stops located? We have it in chat, this question. You can answer it in chat, maybe.
Okay, it's a question about this town.
It is a question by Ruben F. Ampredo. And how are the pedestrian stops located in the city?
Excuse me, pedestrian
Okay,
located.
in the city. Like where are they located? Like some special places for them.
I not special spaces, special stops in the town. I don't hear right your question.
So one moment. So it is
Maybe
in chat. Like
maybe how okay how pedestrian located. One moment. I read question. Located in the based on such location. All transport network located in town Kramatorsk. And many stop location there are in the center of the town where is more transport traffic. And we decided problem with traffic in this town and traffic more speed for 30%.
thank you for your answer. And we are moving to the next speaker. And the next presentation will address the issue of humanity's transition to rational consumption and production models. We invite you to take the floor, Natalia Panteleva. The topic of her report is Raw Material Base of Crushed Stone and Rubble Stone in Khmelnytsky region.
We would like to present the continuation of our research on the mineral resources of Ukraine, which we presented to you at past conferences. Today we present a study of the raw material base of crushed stone and rubble stone in Khmelnytsky Oblast. Podillia region in general and Khmelnytsky Oblast in particular are distinguished by relatively good availability of raw materials for the production of construction materials, including building stones. In recent years, exploration work on this type of raw material has been practically suspended, mainly due to the lack of centralized funding. Exploration work is solely reliant on investors. The existing deposits are mostly small and economically unfeasible for development. Civil and military infrastructure damages caused by Russian-Ukrainian war, along with the inevitable need for extensive post-war restoration works, dictate the necessity of increasing the extraction volumes of construction raw materials, including building stone, a natural resource for crushed stone and rubble stone production. Taking into the account the above mentioned, we consider it significant to analyze the existing raw material base of construction materials in various regions of the country to determine the needs and availability of specific administrative units in terms of different types of construction raw materials and to explore opportunities for their expansion and a rational, efficient utilization. The materials that were used for the research are presented on the slide. In the Khmelnytsky Oblast, the natural stone building material consists of crystalline Precambrian rocks of the platform foundation, including granites, granodiorites, charnokites, migmatites, and gneisses. A total of 21 deposits with balanced reserves of 23,648,000 cubic meters, as well as sedimentary rocks of the cover, such as limestones, dolomites, and sandstones. A total of 27 deposits with balanced reserves of 94,415,000 cubic meters. The granitoids of the Ukrainian shield are characterized by the largest explored reserves, Limestone deposits are mainly small, except for a few medium-sized ones. Concerning explored reserves. Figure 1 illustrates the distribution of building stone deposits in the Khmelnytsky Oblast. The diagram clearly highlights the areas of concentration of magmatic and metamorphic rock deposits. The southwestern slope of the Ukrainian Shield and, correspondingly, the northeastern territories of the region. Figure 2, demonstrating the availability of raw materials for the administrative units of the region and their distribution density, clearly reveals the concentration of the main building stone bases in the northeastern and southwestern areas of the oblast. Availability of raw materials for administrative units in the oblast and the density of its distribution clearly reveal the affinity of the main building stone bases to the northeastern and southwestern regions of the oblast. For instance, Берездівська, Михайлівська, Polonska, Medžibíska, Lytychivska communities have the best provision with explored reserves of building stone. Slightly worse off are Shepetivska, Sudylkivska, Satanivska, and Zhvanetska territorial communities. Other territorial communities in the oblast are either poorly provided or not provided at all with building stone. The total area of building stone deposits located on productive arable lands in the region is 156 hectares, and the reserves of these deposits account for about 16% of the total. The area of deposits currently being developed is 66 hectares in total. The largest reserves of raw material on productive lands are located in Polonska, Kamenets-Podolsky, and Lytychivska territorial communities. Deposits located in unsuitable or forested areas are found in Shepetivska, Slavutska, Starokonstantinivska, and some other territorial communities. Overall, the placement of a significant number of explored raw material reserves in unproductive lands in the region creates favorable prospects for their development in the future. In total, 2,192,000 cubic meters of raw materials for crushed stone and rubble stone were extracted in the region in 2021. As seen in Figure 3, the main volumes of building stone extraction are concentrated in practically free territorial communities: Polonska, Medžibíska, Starokonstantinivska, and partially in Lytychivska and Humenetska, where deposits with significant reserves are exploited. In 5 other communities, the volumes of crushed stone raw materials extraction are insignificant. Expanding the extraction of building stone in the oblast can be achieved either by increasing the volumes in existing quarries in Shepetivska, Polonska, Lytychivska, and some other territorial communities, or by putting into operation the reserve explored deposits 24, of which are located in the oblast. In the administrative units of the oblast endowed with explored reserves, the volumes of raw material extraction have remained generally satisfactory in recent years. However, many western and central territorial communities lack explored reserves of this type of building raw materials and consequently do not engage in its extraction. The capacities of many active mining and extraction enterprises are used extremely unsatisfactorily, typically constituting a few percent. This situation is clearly explained by the current state of the construction material market, both in the oblast and in the country as a whole. Additionally, quarries often remain overless due to the complexity of obtaining licenses for opening new mining and extraction enterprises. The situation may change with a shift in the market conditions in the near future and the much-needed simplification of documentation for obtaining licenses. Increasing the volumes of raw material extraction for crushed stone and rubble stone production in the oblast can be accomplished through achieving design capacities at existing quarries in Shapativska, Polonska, Lytychivska and some other territorial communities, as well as by putting into operation reserve explored deposits, 24 of which are located in the oblast. Large reserves such as Ustivske, Malo-Novoselitske and Konotovske deposits, as well as medium deposits like Medžebiska, and smaller ones being located near highways and railways on non-arable lands are included. Thanks for your attention.
The report is now complete. Dear speakers, thank you. You were very convincing. And dear colleagues, do you have any questions for our speakers? Okay, so we have a question. In your study, you talk about increasing the amount of mineral extraction in the region. And how can the expansion of building stone production be achieved?
Sorry. Thank you for your questions. The problem is very important, and expanding the extraction of building stone in the region can be achieved either by increasing in volumes in existing quarries in Sheptivska, Polonska, Lychkivska, and some other territorial communities of putting of the operation the reserve explored deposits, of which there are 24 in the region. These include the large Yuzevska, Malonovoselivska and Konotopska deposits, the medium-sized Medjibivska deposits, and smaller other located in non-agricultural areas in close proximity of transportation routes, highways and railways. Mitigates the shoots of building mineral in the post-war period can be achieved by creating favorable conditions for the construction of new or restoration of damaged construction plans. For example, providing plots for free use for the first 2-3 years. Moreover, new plants can be exempted for community taxes for the initial period. Receive professional terms for unity connection, and so on. Logistic needs can be partially addressed by creating attraction condition for Western investors. In plans for the production of building materials appear in Ukraine, logistic routes will shorten as well as logistic costs. Thank you. Sorry, my English, I read and translate, but speak very bad.
Thank you a lot for your answer. That was really long and it fully answered our question. We really thank you for your presentation and for your answers. And if nobody has any questions, yes? No, nobody wants to have any question. So we can move to the next speaker. And the 21st century is supposed to become the century of environmentally conscious humanity. And the next speaker will continue our topic of environmental protection. So the next speaker is Natalia Stoyko with the presentation Areas of the Nature Reserve Fund Use in the Context of Sustainable Development. You're welcome.
The topic of our research work is areas of the Nature Reserve Fund use in the context of sustainable development. Sustainable development is currently one of the most important challenges for humanity. The essence of sustainable development is to maximize economic and social benefits from the development of the national economy system while protecting the environment and ensuring the long-term reproduction of natural resources. Nature conservation and environmental protection are recognized as one of Ukraine's priorities in the context of European integration. One of the main objectives of the European Green Deal is to preserve and restore ecosystems and biodiversity. Since 2015, when the UN adopted the 2030 Agenda and 17 Sustainable Development Goals, SDGs, Ukraine's progress in their implementation has been uneven, with serious problems in achieving the vast majority of the SDGs. The implementation of the tasks to ensure the protection of ecosystems and biodiversity, SDG 15, has partially stopped. The implementation of the policy aimed at protecting and restoring terrestrial ecosystems, including the preservation and expansion of the territories of the Nature Reserve Fund in Ukraine, has brought about certain positive changes, but unfortunately has not allowed for the dynamics necessary to approach the targets on the horizon until 2020. However, such rates do not allow to achieve the target benchmarks, 6,276.9 thousand hectares and 10.4%, respectively. One of the key current problems in the field of nature reserves funds, NRF, in Ukraine is the lack of clearly defined boundaries of nature reserves at the regional level and the unresolved issue of their introduction into nature. The main reason for this is the lack of funding for the development of relevant land management projects, since the boundaries of NRF's territories are determined only after the allocation of funds for their introduction into nature, that is, after the creation of NRF territories and not at the stage of their formation. As of January 1st, 2023, the Nature Reserve Fund of Kharkiv region includes 247 protected areas, with a total area of 74.877 thousand hectares. The proportion of the area of the Nature Reserve Fund in the area of the administrative unit is 2.4%, which is one of the smallest in Ukraine. The fact that the state strategy for regional development until 2020 stipulates that the amount of land in the Nature Reserve Fund of Kharkiv region should be 282.735 hectares at the beginning of 2020, which is equivalent to 9% of the total area of the region, indicates a low level of measures to increase the percentage of the region's territory reserved. In other words, the percentage of the territories allocated for the reserve fund does not meet the planned indicators. During 2021, at the initiative of the regional state administration, there were attempts to expand the lands of the region's nature reserve fund, but no final decisions were made. We estimate that if measures had been taken to include the territory in the region's nature reserve fund, which is 71,450.5 hectares, the percentage of the actual area of the NRF to the area of the administrative unit would have been 4.65 versus the actual 2.4. Thus, there are certain difficulties in the process of creating new and expanding existing protected areas in Kharkiv region. The prospective directions of development of the Nature Reserve Fund of Kharkiv region can be presented by the following structural and logical scheme. This logical structure can serve as a basis for the development and implementation of the strategy for the development of the Nature Reserve Fund of the Kharkiv region. One of the promising areas for increasing the area of land in the Nature Reserve Fund of Kharkiv region may be at the expense of territories reserved for the creation of new or expansion of existing nature reserve objects, creation of ecological corridors, and the land reclamation. For example, in the Krasnokysk community of the Bahadukhiev district of the Kharkiv region, the inclusion of reserved areas in the lands of the community's ecological network will increase its area. The existing area of the Nature Reserve Fund is 1,091.6 hectares and will amount to 11,475.5 hectares, while the area of the Nature Reserve Fund will be 1,300 25.5 hectares, which will be 1.27% compared to the existing 1.05% of the total area of the community. The prospective territories of the Nature Reserve Fund in the Krasnokuts community of the Kharkiv region are shown in tables 3 and 4. In order to intensify the processes aimed at achieving Goal 15 in Ukraine, it is necessary to intensify the work of local authorities to create new territories and objects of the Nature Reserve Fund, to promote the transition in organic agriculture to preserve and improve soil fertility and biodiversity, reduce land and water pollution, artificial pesticides or herbicides, etc., to ensure effective management of territories and objects of the Nature Reserve Fund of local and national importance, including increasing the amount of financial resources allocated for the conservation of the Nature Reserve Fund, to ensure improvement of economic mechanisms to stimulate land protection and restoration of soil fertility, to ensure the regulation of the transformation of the country's land structure, reduction of arable land, increase of forest cover, restoration of hayfields and pastures, etc. In the process of decentralization of power and transfer of land from state ownership to the ownership of united territorial communities. Thank you for your attention.
Thank you for the presentation of your research. It was really informative. And the audience has some questions. And the first question from Svetlana Mantulenko sounds this way. Which models of managing the Natural Reserve Fund in the context of sustainable development do you consider to be the most effective?
Thank you for your question. So the effectiveness of managing the Natural Reserve Fund depends on a number of factors, and it includes environmental, economic, and social aspects. The most effective models of managing the Natural Reserve Fund are, in particular, those that ensure a balance between the conservation of natural resources and their sustainable use for societal needs. Now I'm going to list some models, a few of them, that we consider effective. So the first one is integrated resource management. This model involves the integration of the management of all natural resources within protected areas, taking into account the needs of different users and stakeholders. Then co-management or joint management, which entails a partnership between government agencies, local communities, non-governmental organizations, and the private sector in managing protected areas. Another one is adaptive management. This model is based on the principle of flexibility and continuous improvement of management approaches based on monitoring and evaluation of results. Regional conservation networks is another one, which involves creating a network of protected areas that work together to conserve biodiversity at the regional level, ensuring ecological integrity and connectivity between different protected zones. And the last one, but not the least, is public-private partnership. This model involves cooperation between government agencies and private investors for the management and development of protected areas. So that's it.
Thank you a lot for your answer. And we have the second question, again from Svetlana Mantulenko. And this question sounds this way. Which international programs and initiatives could be beneficial for the development of Ukraine's Natural Reserve Fund?
There are various international programs and initiatives that are aimed at biodiversity conservation, sustainable development, or environmental education, which can be beneficial, and we have a list of them. For example, United Nations Environment Program, which supports various projects aimed at environmental protection, sustainable development, and biodiversity conservation. It provides technical assistance, conducts research, and implements educational initiatives. Another one is UNDP, United Nations Development Program, which implements projects that promote sustainable development, including environmental protection, strengthening natural resource management, and supporting local communities. Also, Global Environment Facility, or GEF, which funds projects aimed at biodiversity conservation, combating climate change, and land degradation. The fund works in collaboration with governments, international organizations, or non-governmental organizations, NGOs. Nature 2000 network, which is a network of protected areas in the European Union created to conserve species and habitats of European importance. And although Ukraine is not a European Union member, it can collaborate with Natura 2000 through various programs and projects. Next one is the International Union for Conservation of Nature. It's one of the largest and oldest global organizations dedicated to nature conservation, and it brings together governments, NGOs, scientific institutions, and private companies to work on these problems. Then we have two conventions. First one is Convention on Biological Diversity, or CBD. This is an international agreement that aims at biodiversity conservation, sustainable development, and the fair sharing of benefits arising from the use of genetic resources. Another one is the Ramsar Convention, or another name for it is Convention on Wetlands. The Ramsar Convention focuses on the conservation and wise use of wetlands through national actions and international cooperation. And the last one is United Nations Economic Commission for Europe. It implements projects in sustainable development, including environmental policy, water resources, and climate change. That's it. Thank you.
Thank you. So you named 8 of such programs. Am I right?
Yes, exactly.
Okay, thank you. So we can move to the next speaker. And the next speaker will continue the topic of sustainable development, in particular the conservation and sustainable use of oceans, seas, and marine resources for sustainable development. We would like to invite you to take the floor, Mykola Petrushenko, with a presentation on trends in variability of the distribution of particulate organic carbon in the northwestern part of the Baltic Sea. You are welcome.
The paper describes the results of a study of the variability in the distribution of particulate organic carbon (POC) concentrations in the northwestern part of the Black Sea. Coastal ecosystems are among the most productive on Earth. They provide essential ecosystem services such as coastal protection from storms and fish feeding grounds. They are also known to provide another essential service, the sequestration and preservation of blue carbon from the atmosphere and oceans, and are therefore an important part of solving the problem of global climate change. The dynamics of the particulate organic carbon pool in the ocean is essential to the marine carbon cycle. POC is the link between surface primary production, the deep ocean, and sediments. It is known that the rate of POC decomposition in the dark ocean can influence atmospheric carbon concentrations. The European Commission has developed criteria and indicators for assessing the sustainability of the blue economy. The components of sustainability measurements in the storage of carbon sequestration subsector are carbon dynamics, carbon valuation, climate change. The research process was based on the following stages: formation of POC databases, build of POC spatial distribution maps, analysis of the variability of the spatial distribution of POCs by season between 2000 and 2023 in their overall distribution over the entire period, and identifying trends. The initial information for the research was satellite data of particulate organic carbon in the period from 2000 to 2023. The data were measured by NASA's Terra Modis satellite. Processing of raw data was carried out using MATLAB software. Verification of POC satellite data processing was performed using specialized NASA software series data analysis system. Maps of the spatial distribution of POC in the northwestern part of the Black Sea were built using Ocean Data View software. The ODV software is designed for interactive exploration and graphical display of oceanographic profiles, trajectories, or time series data. The statistical characteristic beta POC characterizing the variability of POC concentration per year was calculated using a well-known equation on the slide. Identification of trends in POC variability was carried out on the basis of graphical material built using averaged satellite data in the period 2000-2023. Studies of POC variability have been concentrated in the northwestern part of the Black Sea. After all, it is known that in this part of the Black Sea there are ecosystems that with a high probability contain the carbon. This is the world's largest colony of red algae, the Zernos, the Lofora field. There are also 7 wetlands of international importance along the coast. The findings are follows. The first, formation of POC concentration databases for conducting research in the northwestern part of the Black Sea. Satellite observation data from 2000 to 2023 were used to build maps of the spatial distribution of POC concentration by season and in general for the entire period. The number of average data for the studied period was about 9,500 measurements for the seasonal distribution of POC. Analysis, their second, analysis of the variability of the spatial distribution of POC concentration in the northwestern part of the Black Sea. Maps of POC distribution in different seasons were built to analyze the variability of the spatial distribution of POC concentrations in the northwestern part of the Black Sea. Average POC data for the period 2000-2023, which were formed into the appropriate database, served as initial data for building maps. Build maps are shown in Figure 1. In Figure 1a, for example, the maximum concentration of POC is observed along the coast from the Yegorlitska Bay to the Kiliski mouth, as well as in the area of the Jarligaska Bay. From these areas with the maximum concentration of POC, this decrease spreads to the south of the northwestern part of the Black Sea. To visualize the general spatial distribution of POC concentration in the northwestern part of the Black Sea, a corresponding map was built, Figure 2. Figure 2 shows that the maximum concentration of POC extends behind the cyclonic movement along the coast from the Yegorlitska Bay and the Tendrivska Bay and the Danube Delta, as well as in the water area of the Kalkinitska and Jarligatska Bays. The third, identification of POC concentration distribution trends in the northwestern part of the Black Sea. To analyze the intra-annual distribution of POC concentration in the northwestern part of the Black Sea, The corresponding graph was built, figure 3. The initial data were satellite data of POC concentrations average for each month in the period 2000-2023. For figure 3, it can be seen that the maximum concentration of POC is observed in December-January and is about 647 milligrams per cubic meter. To identify trends in the distribution of POC concentration in the northwestern part of the Black Sea, a graph of its interannual variability was built, figure 4. Satellite data of POC concentration averaged for each year in the period 2000-2022 served as initial data. Those conclusions are the follows. Based on the obtained calculation results, it can be asserted that the variability of the concentration of POC in the northwestern part of the Black Sea has a seasonal character with the annual periodicity with the cyclonic movement of POC along the coast. The maximum concentration of POCs is generally concentrated in wetlands in the international importance, indicating that they perform much broader ecosystem functions than filtering and purifying water. These wetlands store blue carbon, occupying a certain link in the marine carbon cycle. This confirms the important role of these coastal ecosystems within the transition of the blue economy of the studied area of sustainable development, namely increasing the contribution to solving climate and biodiversity problems in accordance with the Sustainable Development Goals. Insufficient consideration of this role in the relevant decisions, in particular according to the Ramsar Convention of Wetlands, will lead not only to a decrease in biodiversity, but also to a deterioration of the climate within the territory of the northern Black Sea. Considering the fact that a large part of these territories has suffered damage as the result of military operations and or in under Russian occupation, the situation is very difficult. The task in the wartime is to preserve the health of the studied ecosystems as much as possible with the involvement of specialists and observers of regional and national as well as international levels. The post-war period will require the recovery of wetlands as well as the development of a national blue carbon strategy within the coastal ecosystems of Ukraine. Thank you for your attention.
The report is now complete. Thank you a lot for such a detailed presentation. Colleagues, do you have any questions? Oh, so we have one question in chat. The question from Ruben and Prado. So how did you collect your POC data? How do you define and identify POC in the NASA satellite images? How are red algae related to POC? What could be account to the decline in the POC milligrams meter in third and from 2000 to 2023 in the Northwest Black Sea?
Thank you. First of all, good afternoon, everyone. Thank you for our conference. I have some English skill difficulties in answer these questions, many questions. But I try using some materials to answer. The initial information for the research was satellite data of particulate organic carbon, PRC, in period from 2000 to 2023. The data were measured by NASA's Terra MODIS satellite. Processing of raw data was carried out using MATLAB software. Verification of PRC satellite data processing was performed using specialized NASA software Kryvyi Rih data analysis system. Maps of the spatial distribution of PRC in the northwestern part of the Black Sea, and in particular red algae, were built using Ocean Data View software. The ODV, Ocean Data View software, is designed for interactive exploration and graphical display of oceanographic profiles, trajectories, or time series data. From a sustainability point of view, our research have some positives for climate change, for policy, for some policy decisions. In particular, the components of sustainability measurements in the storage of carbon sequestration subsector. We have 3 indicators in such subsector: carbon dynamics, the first, carbon valuation, second, and climate change, the third. Also I can say that our findings are follows and consistent 3 main parts. The first, formation of PRC concentration databases for conducting research in the northwestern part of the Black Sea, mainly is Ukrainian coast. The second, analysis of the variability of the spatial distribution of PRC concentration in the northwestern part of the Black Sea. And the third, identification of PRC concentration distribution trends in some territories in the northwestern part of the Black Sea. This is my answer. Thank you.
And while you were answering, we have one more question. How sure are you that the satellite data pertain to POC and not other else?
In our research, we concentrate on red algae and particulate organic carbon. But we have other information data, but the complexity view is not our research sphere, but our findings have the main conclusion, and the conclusion is the following. Based on the obtained calculation results, it can be assumed that the variability of the concentration of PRC in the northwestern part of the Black Sea has a seasonal character with an annual periodicity with the cyclonic movement of POC along the coast. And the maximum concentration of POCs is generally concentrated in wetlands of international importance. It's very important for international policy, in wartime especially.
Thank you a lot for your answer.
That's all.
And we have one more question. What mapping software did you use to map the results of your research?
Okay, thank you. This related to our second finding. Maps of POC distribution in different seasons were built to analyze the variability of the spatial distribution of the POC concentration, and the data were measured by NASA's Terra MODIS satellite, and processing of raw data was carried out using MATLAB software. Verification of POC satellite data processing was performed using specialized NASA software, CVIFS data analysis system, and maps of the spatial distribution of POC in the northwestern part of the Black Sea, Ukrainian coast, were built using ocean data view software. That's all.
Thank you a lot for your answer. That was the last question for you. Thank you. And a short announcement for Ukraine. And if there is an air alert in your area, please take shelter and join us from there. And now we continue our work. No less important in the context of our conference theme is the issue of sustainable development of settlements and population. The following speakers will present a retrospective study. So we invite Bondarenko Olha and Ihor Holoshin to make a presentation, the usage of GIS into the retrospective analysis of the territorial organization of Kryvyi Rih settlement. You're welcome.
Good afternoon. Let us present the results of our research on the topic, the usage of GIS in the retrospective analysis of the territorial organization of Kryvyi Rih settlement. The study of landscape dynamics is crucial for determining the anthropogenic impact on the transformation of technologically disturbed geosystems. Kryvyi Rih, with over 130 years of excessive mining and mineral processing, is a prime example. The purpose of the publication is to reconstruct the anthropogenic effect on the transformation of natural landscapes by means of retrospective analysis of the process of territorial organization of Kryvyi Rih settlement. The primary purpose comprises three research tasks, which you can see at the screen. The retrospective research admittedly uses two main sources of information which reflect the state of the territory in a certain period of time, various historical texts and cartographic materials of different times. This publication uses a number of historical text materials that reflect the development of Kryvyi Rih area. However, we know that these sources provide unsystematic and episodical accounts of the settlement of this territory of the studied region, and mostly without spatial visualization. The analyzed material sometimes manifests significant content contradictions, which require further determination of the validity of the presented spatio-temporal data. Cartographic materials of the studied territory are represented by a number of historical maps created over 3 centuries of topographic research. The main ones are map of the Polish-Lithuanian Commonwealth, special map of the western part of the Russian Empire by Schubert, 3-mile military topographic map of the Russian Empire, the maps of the Office of Military Topographers of the Red Army, the maps of the German Army, topo maps of the US Army, and maps of the General Staff of the USSR Armed Forces. These maps the environmental changes and were key tools in our analysis. To establish the settlement timeline and demographics, we analyzed cartographic works across periods, comparing depicted settlements, locations, and symbols to determine their spatio-temporal characteristics through cross-analysis of multiple historical sources. For example, Kryvyi Rih had 460 yards plotted on Schubert's 1849 map, but 770 yards on the 1888 Russian military map. So we can conclude that the data visualized on the Schubert map correspond to 1810 and on the 3-mile map to 1882. We make similar diagrams for other cross-cutting settlements, which help determine the temporal intervals of the correspondence of the data plotted on these maps. Analogically, the population of Kryvyi Rih city on the map of the General Staff of the USSR Armed Forces, created in 1990, corresponds to the time range of 1985-1987. To fill the data gaps, we analyzed historical documents in order to establish the correlation between the number of yards and their population on the territory of residence, excluding large settlements with detailed records, since the historical and statistical information about them is quite detailed. The diagram shows the close correlation between the number of yards and their population on the territory of residence, crossing the pairwise correlation coefficient is plus 0.89. So the number of yards in Kryvyi Rih area allows to calculate with a high degree of reliability spatio-temporal indicators of the population for all analyzed time segments. The resettlement of Kryvyi Rih area began in the middle of the 16th century, when it became part of the Zaporizhia Nizovy Host until 1775, the end of the Zaporizhia army existence. Analysis of the map using the heat map method demonstrates that settlements initially had a linear distribution along rivers, as proximity to the river network was the key natural factor shaping the early structure. At the beginning of the 19th century, the number of settlements in Kryvyi Rih area tripled due to the resettlement of a significant number of serfs from different parts of Russian Empire and on the emergence of Jewish settlements. The settlement structure of the region at that time almost didn't change. At the end of the 19th century, the number of settlements in Kryvyi Rih area doubled due to their location on vacant land between previously built settlements. It resulted in a transition form of linear structure of settlement of the region to a linear planar one. From the middle of the 19th century, Kryvyi Rih turned into a significant agricultural and trade center of southern Ukraine. Since then, the development of Kryvyi Rih was affected by its growing economic role. The transformation of Kryvyi Rih into a big economic center affected the location and functioning of virtually all settlements of Kryvyi Rih area. The territorial organization of the population changed. A set of processes or actions that regulate the interrelation between the popular location and production, interconnection, and subordination. The rural settlement networks significantly changed its role in the general system of settlement of the region, since at that time it acquired a secondary role in the economic development of Kryvyi Rih area. Virtually, a gradual transition from natural to economic factors of settlements structure formation took place at that time. The active process of resettlement of peasants during the period of the Stolypin reform and mostly the abolition of landlord land ownership by the decree on land, which the subsequent distribution of allotments among peasants contributed to the active development of almost the entire territory of the region. According to the 1982-86 Soviet military map, while the overall settlement count was similar to 1930, historical sources indicate an initial increase until the mid-20th century, followed by a decrease aided by the region's fertile soils, geography, and irrigation supporting rural network growth. The identified trend of changes in the nature of settlement of the region is manifested in changes in the average distances between settlements of Kryvyi Rih, their number and the density of their location during the settlement of the territory. The identified trend of changes in the nature of settlement of the region is manifested in changes in the average distances between settlement of Kryvyi Rih, number of settlements in Kryvyi Rih, and the density of their location in different periods of settlement. Analyzing the spatio-temporal differentiation of the region's population density indicator, the following can be noted. At the end of the 18th century, two centers of development were noted: Kryvyi Rih in the center of the region and Lozovatka in the north. Population placement at that time was uniform. The end of the 19th century, the third population center in the south of the region, the colony of Inglets and the village of Shiroke, came into being, making the main changes in the spatial structure of quantitative indicators of population displacement. Since the middle of the 20th century, a linear zone of population density has been clearly distinguished, which marks the territory of the city of Kryvyi Rih as the territory of maximum density among the low indicators of the rural settlement network. After the analysis of changes in the population of the cross-cutting settlements of the region, we divide them into three groups according to the dynamics of changes. The first group is characterized by a sharp increase in the number of the population in the second half of the 20th century. The city of Kryvyi Rih and settlement, as well as settlements located near it, which are under its high economic influence. The second one illustrates the regular statistical distribution of the population indicator. These settlements with regressive population trends often former Jewish agricultural colonies. And the third group comprises settlements with a stable dynamic development of demographic indicators. This includes the villages which are distant from Kryvyi Rih, so the city economic influence is insignificant. Thank you for your attention.
We thank speakers for their interesting presentation. And now we are ready to ask a few questions. And one of the questions, we have it in chat. So the question sounds this way. Please tell us if you had any difficulties during the study. And we have the answer, so I will read it. The study of historical maps of Kryvyi Rih raises a number of challenges, such as map pure quality depiction, crumpled and worn sheets, unclear printing, etc. Different mapping and nomenclature of maps cause variation of location of the research area in different sources, on one or several sheets. On most maps, the legend is missing or presented in a very simplified version. Maps differ significantly in terms of their mathematical basis, such as scale, longitude, cartographic projection, length measurement system, etc. The maps differ significantly in toponymy. For example, the modern name of the village Sofiivka has undergone the following changes since its foundation to the present day. Sofiivka, Sofievo-Heikivka, Sofievo-Valove. The described difficulties that significantly complicated the analysis of spatial indicators of different time cartographic works. Quantitative characteristics of various temporal indicators of the studied territory demonstrates almost the absence of systematic and full-fledged information about the specifics of the population settlement of Kryvyi Rih area in certain periods of time, despite a significant number of historical documents. We pay special attention to conflicting data present in various historical materials regarding the population, both of the region in general and of individual settlements in different periods of the settlements of Kryvyi Rih area. And to fill the identified gaps, we additionally study historical documents in order to establish the correlation between the number of yards and their population on the territory of residence. However, the calculations do not take into account the indicators of large settlements, such as Kryvyi Rih or Lozovatka, etc., since the historical and statistical information about them is quite detailed. So that was the answer for the question, if the authors had any difficulties during the study. Are there any questions? So if you will have any questions, you can write them in chat and you will be answered. And we are moving to the next presentation. Good health and well-being is one of the Sustainable Development Goals. The world is still recovering from the consequences of the pandemic that shook it a few years ago. So, Mantulenko Svetlana will present the results of her research, in which she will reveal the differences and similarities in the geography of the COVID-19 pandemic in Ukraine and in the world. We invite you to take the floor.
Gentlemen, we would like to introduce you the presentation of our research. The topic of our research is Geography of the COVID-19 pandemic in Ukraine and the world, similarities and differences. The COVID-19 pandemic will go down in the history of humanity as one of the most important events of the first quarter of the 21st century. It has caused unprecedented consequences in both political and socio-economic spheres of all countries. The result of that, the scientific community is widely interested in addressing absolutely all aspects of the pandemic. The researchers used a wide range of geospatial and statistical software, and the examples of them were clustering, hotspot analysis, spatio-temporal scan statistics, and regression modeling. Such studies allow developing territorial forecast models of the pandemic, creating various medical and cartographic materials, the examples of which you can see in the breaks. The purpose of the research is to conduct a geospatial analysis of the spread of COVID-19 in Ukraine and the world, identifying similarities and differences. The work is based on the synthesis of monitoring and geoinformation approaches to the study of a new coronavirus infection, and the quantum geoinformation application was used as a geoinformation platform. The COVID-19 coronavirus pandemic has been going on for over 3 years. During this time, it has spread all over the world, and with more than 765 million cases of infected people recorded, according to official data. And the disease has taken millions of lives. In Ukraine, the first case of COVID-19 coronavirus infection was confirmed on March 3 of 2020, and the patient arrived in Chernivtsi from Italy, where he had been traveling from February 21st till February 26th. Later cases of infection were detected in Khmelnytsky, Odessa, Donetsk, Kharkiv, Zaporizhia, Kherson, and Vinnytsia regions. Epidemiologists call the first patients people who returned from foreigner trips, where they could have got COVID-19. For instance, patients in the eastern regions returned from Egypt and Europe, particularly France. In the western, from Austria, Hungary, and Italy. In southern regions, from United Arab Emirates, Egypt, the United States, and European countries. The mechanism of the virus infection in Ukraine is similar to the global one, from the primary source to the chain of contacts with the infected. However, due to the lack of direct flights to Wuhan, China, Ukraine received the virus after its long transit through other countries, which is almost 2 months later than countries in Asia, Europe, and America. This temporal discrepancy has been observed throughout the pandemic. This conclusion is best illustrated in figure, which shows the temporal correlation between the waves of disease development in the world and Ukraine. From this graph, we can identify 4 waves in the development of the disease, both globally and in Ukraine. The figure shows a horopleth map of the distribution of number of detected cases of COVID-19 infection and the world in the end of the pandemic. At the end of the pandemic, according to World Health Organization, the 5 countries most affected by coronavirus infection were the United States, India, France, Germany, and Brazil. If we analyze the quantitative composition of the 30 countries with the highest incidence rates, most of them are from Europe and Asia. In terms of the absolute number of cases, the countries with largest populations are leading the way. Only African countries are absent from this ranking. It is worth noting that, for the most part, regional patterns of the pandemic, both at the country level and the larger scale, are almost identical. The development of the pandemic in Ukraine is an example of this. Thus, the spatial differentiation of number of detected cases of COVID-19 infection in Ukraine at the end of the pandemic generally corresponds to distribution of the population by regions of the country in the pre-war period. The regions with the largest population have the highest number of cases, and the smallest have the fewest cases, respectively. At the same time, the nature of the histogram showing the temporal change in the number of confirmed cases of infection is almost identical for all regions of Ukraine and differs only in absolute terms of the pandemic. However, from the February of 2022, Ukraine experienced quite big migration processes from the war zones due to Russia's military aggression. Also, parts of the country's territory was and is under occupation. Therefore, if we analyze the map of the distribution of number of detected cases of COVID-19 to the number of people, we can clearly see the zonal distribution of this indicator. Its value increases in the direction of south-north and east-west. This spatial differentiation is explained by migration processes, and the number of people, and accordingly the number of COVID-19 cases in the northern and western regions has increased significantly due to migration from frontline areas to the south and east areas of Ukraine. The main consequence of coronavirus is sharp increase in mortality, in global mortality. At least 7 million people have died during the coronavirus pandemic, even though the researchers believe that the number is quite much bigger and reaches around 20 million people. The Coroplast map of coronavirus does actually duplicate the map of the spread of the infection in the world. The main reason for this is the close correlation between the total number of infected and deaths. The correlation coefficient is plus 0.88, but there are exceptions. The map showing the spatial differentiation of mortality from COVID-19 looks radically different. This indicator shows the number of deaths from the coronavirus relative to the total number of patients from the pandemic for each country. In fact, this indicator demonstrates the effectiveness and the accessibility of social security and healthcare system in the countries around the world. So the average death rate from COVID in the world was 0.99%, and most countries in Africa and Latin America had the highest mortality rate, until 7%. As of 29th of June of 2023, the coronavirus mortality rate in Ukraine averaged 2.02%, and it's twice the global rate. The highest mortality rate from coronavirus were recorded in Kirovohrad, Luhansk, and Dnipro regions. The lowest rate were recorded in Rivne, Ternopil, and Volyn regions. As a result, there is a pronounced spatial differentiation of COVID-19 mortality rates on the map of Ukraine. The southern and eastern parts of the country have the highest mortality rate, which is over 2.3%, and the northern and northwestern parts have the lowest, which is less than 1.7%. According to the quantitative characteristic of two main indicators of epidemiological course of COVID-19, which is detected cases and mortality, all regions except the Autonomous Republic of Crimea can be divided into 4 groups. The first group includes Zakarpattia, Chernihiv, Kirovohrad, Kherson, and Luhansk region. This region had the lowest number of patients with coronavirus infection, which is less than 150,000 people, and we have an above average mortality rate, which is 2%. They have low population density, they have demonstrated some difficulties in the healthcare system, ability, and etc. The group 2 includes Sumy and Cherkasy region, and most regions in the western part of Ukraine, such as Volyn, Rivne, Zhytomyr, Ivano-Frankivsk, and etc. They have the lowest mortality rate, 2%, with average number of detected cases from 150 to 250,000. These are regions with the best epidemiological situation of the pandemic. Third group consists of Chernivtsi, Vinnytsia, Mykolaiv, Poltava, Zaporizhia, and Donetsk regions. The mortality rate there about 2%, and average number of detected cases is from 150 to 250,000. The group 4 consists of Kharkiv, Dnipro, Kyiv, and Lviv regions, and these are regions with the highest mortality, 2%, and morbidity 250,000 in Ukraine. The course of the pandemic in Odessa region should be noted separately, because with the largest amount of detected cases, which is almost 360,000, the mortality rate in the region was recorded at 1.74%. And this can be explained by the most favorable climatic and environmental conditions in the regions. Based on the results of geospatial analysis, although geographical map of Ukraine zone according to the epidemiological course of the COVID-19 was constructed, and it reflects the spatial differentiation of the pandemic parameters, which is associated with various and multi-directional factors that determine the course of the pandemic. And the main ones of them: A, population density. Regions with the highest population have the highest morbidity and mortality rates. B, spatial mobility of the population, external and internal migration of the population, which made a big impact on the spread. And C, the peculiarities of regional management. So the development of the situation was quite much dependent on the quality of management decision made by regional and city authorities.
Thank you a lot for your interesting presentation. And we are ready to ask a few questions. Anastasia Valesco, please.
Thank you so much. Thank you for your presentation. It was really, really interesting. And my question is, what geographical factors influence the spread of the COVID-19 epidemic?
Hello, dear participants. Thank you for the question. Sorry. Scientists have how the COVID-19 is positively correlating with temperature and humidity. That's why at the beginning of the first wave, COVID fell on countries with monsoon climate: Turkey, Iran, Italy, Spain. Other factors include population, sincerity population, composition, travel patterns, and internal migration.
Thank you for the answer.
Thank you a lot for your answer. And we have one more question. Could you please tell us where you got the accounting and statistical data for the study?
Thank you for the questions. With your permission, I will answer in the chat.
Okay, so I will read your answer. The work is based on the synthesis of monitoring and geoinformation approaches to the study of the new coronavirus infection. The main parameters of geoinformation monitoring include a variety of data sources and visualization of the dynamics of the processes under study. The statistical basis of the study is the materials from the official websites of global and Ukrainian organizations such as World Health Organization, Johns Hopkins University, UNICEF, Ministry of Health of Ukraine, etc. Thank you a lot for your answer. Does anybody have other questions? So nobody has any questions, and we can move to our final speaker. The final presentation will focus on another very important aspect of sustainable development: improving the resolution of land surface temperature using multivariable linear regression from Landsat 8 and Sentinel-2 images. A case study in Ho Chi Minh City. Presented by Ha Tuan Quang and Ha Phong Thi. And I have a question. Do we have such speakers here? So we don't have these speakers. And so that was the final presentation. And we would like to thank everyone for participating in our conference. So today we devoted our time to the problems of sustainable future. We were discussing sustainable development. That development that meets the needs of the people of today without compromising the ability of future generations to meet their own needs. And we would like to thank everybody who was presenting. And so we would like to thank Aola Yusfi for a real informative presentation about carbon dioxide, CO2 emissions. That was really fruitful. We had a real fruitful dialogue after that. Really, thank you a lot. We would like to thank Sergeant Malik. Sergeant Malik was talking about plant-based dairy alternatives, and that was really informative. Thank you a lot for participating. We would like to thank Judeline Petro, who was making presentation about below ground carbon stock of mangrove stands. That was very interesting topic, and thank you a lot for it. We would like to thank Olena Pomortseva, who was making a presentation on the topic application of geoinformation systems in the development of the city's intelligent transport network. Thank you a lot. It was really interesting to listen about how the city's transportation is working. Also, we would like to say thank you to Natalia Pantileva, whose presentation was addressing the issue of humanity's transition to rational consumption and production models. Thank you a lot. And we would like to thank Natalia Stoiko, who was talking about environmental protection. To be more specific about areas of the National Reserve Fund used in context of sustainable development. Thank you, Natalia Stoiko, so much. Also, we would like to say thank you to Mykola Petrushenko, who was continuing the topic of sustainable development, in particular the conservation and sustainable use of oceans, seas, and marine resources for sustainable development. It was really interesting to listen to and talk about the sea and the ocean. Also, we would like to thank Bondarenko Olha and Ihor Holoshin and for their presentation about the issue of sustainable development of settlements and population. Again, after listening to development of sea and ocean, it was really interesting, and we heard a lot of new information about development of settlements and population. So thank you for such an interesting presentation. And we would like to thank our last speaker, Mantulenko Svetlana, who was talking about health and well-being, which is one of the most sustainable development goals. And we would like to thank about this beautiful presentation about geography of the COVID-19 pandemic in Ukraine and the world, about its similarities and differences. So thank you, everyone. Thank every speaker and every listener who was here in our conference. And also, I see your feedback commentaries. Thank you a lot. We were really glad to hear feedback. If somebody wants to say something, you are welcome. because I see a lot of commentaries in chat. Okay, I see a lot of commentaries again. And also, we would like to inform you that this conference is not the last one in the huge international conference. It's only a small part. So the second session of our conference is going to be this Friday. So we would like to demonstrate the screen, and here you can see the plan of the next conference, which is going to be this Friday morning. So you will listen to another bunch of authors and their different presentations, which again differ from different topics, from some close to nature things and to human-built things, which again connected to nature and sustainable development. So we will listen to resource-saving method of extracting cucumber and melon seeds. We will listen to methane degassing within Ukraine according to satellite data. Also, we will have a presentation about assessment of trends in the functioning of the grain industry of the EU countries using ARDL modeling. Also, there will be a beautiful research about seismic hazard assessment in the Shamkir Michavir reservoir region through ground response analysis. And we will have such research about accumulation of heavy metals by different representatives of biota in the operation zone of the Pridniprovska thermal power plant. And after it, we will listen to development of spatial optimization models of social-natural interaction as a way to sustainable development. And that is only the half of our Friday plan. Also, we will listen to prospects for using composite preparations on silica nasalons. And we will have a presentation about geospatial database generation of forest growth using the QGIS software package. And there will be such a presentation about the influence of organic agriculture development processes of the country's economic security components. And we will listen to geoinformation assessment of solar plant potential in the Ivano-Frankivsk region to achieve effective decarbonization and energy stability. And we will have the last 5 presentations, which are again closely related to every part of our life. So we are looking for everyone to take part in this conference, which will be this Friday at 11 a.m. Ukraine time. Thank you a lot. So we are looking forward to everyone. We are looking for your questions, for your being there. Thank you a lot for taking part in today's conference. And thank you for all your commentaries here. So that was really a pleasure to meet with you. Thank you a lot. And also, we want to thank you for finding the time to join us once again. We see all your thanks, and that makes us happy, and happy. And we are looking forward to further cooperation and for Friday morning. Take care of yourselves. Goodbye.